Calculate the distance between the points f equals -1, and g equals 5, -9 in the coordinate plane. Give an exact answer. Do not use a decimal approximation. First thing you want to do is write the distance formula. What is the distance formula between 2 points? If you haven't already, I highly recommend that you keep a formula sheet whenever you're studying a math class. So create your own formula sheet. It might go, it might even go over 1 or 2 pages, but keep these formulas all on one page and then put them in front of your homework binder. That way you have a glossary of formulas that you've encountered as you're doing your homework. So let's write the distance formula. And keep in mind, this will always yield a positive answer. So this will always be greater than 0. Okay, it is an expression. So we'll go ahead and evaluate d. D is going to be the square root of, well, we could label x1 and x2, so you can call this x1, y1, sorry. And then this is x2, y2. I don't like my little y1 there. Why don't I make that bigger? x1, y1, bigger. Okay, I'll make this other one bigger too so you guys can see it. Let's see here. x2, y2, bigger. All right. Well, let's do x1 minus x2. Just make sure you're following the order of operations here. So we have x1, which is -1, minus an x2, which is 5, and then you square it, add it to, what does it see here? y1 is -1, and then subtract y2, so subtract y2, y2 is -9, and then square it. And of course, do order of operations. Order of operations says do the innermost parentheses first. So we're going to do -6 quantity squared plus 8 quantity squared, and we get 36 plus 64. Isn't that cute? Why is that so cute? Because that is the square root of 100, and that yields a distance of 10. So the distance is 10 units. Might as well circle your work. Notice this problem is about expressions. It has nothing to do with equations. It's really about expressions. And let me point that out to you. Start with the expression d. And d is this expression, is this expression, is this expression, is this expression, and it's that expression of 10. So this is really just a manipulation of expressions. Let's find the midpoint M of the line segment joining the points A equals parentheses -2, comma, -3, parentheses, and B equals parentheses -6, comma, 7, parentheses. And here's a little illustration of what's going on. There's actually a line segment that's actually taking up the space in quadrant 2 and quadrant 3, and our goal is to find the midpoint M here. So the speculation is, what is that? Can we find it? And is there a formula for it? Well, yeah, of course. If you haven't already, make a formula sheet for yourself and write down all the formulas in this class and put it in the front of your homework binder. That way you have a glossary of formulas and you're ready to use them whenever you encounter them. And it's always good to review and just try to memorize the formulas on your own. The midpoint is not bad. It looks like the average or the halfway point between the two endpoints. So let's write down the midpoint formula. So if you're given, let's say, 2 ordered pairs, that's an x2, then the midpoint formula is what? The midpoint M is equal to parentheses x1 plus x2 divided by 2, x1 plus y2 divided by 2. And there is the midpoint formula. It simply is the average of the two endpoints, one in the x direction and the other in the y direction. Let's go ahead and compute that. The expression is m, and we have parentheses. x1 we said is negative 2, and then b is x1 is negative 2, and then we're going to add x2, which is negative 6, and then divided by 2, comma, negative 3, add 7, and put that over 2, and then close that with a parentheses. The midpoint is negative 4, and then 2. Now, is that reasonable? Does m look like negative 4 and 2? I believe so. I think that's reasonable, because the answer should be in what? The answer should be in quadrant 2, and that is a coordinate in quadrant 2. So why don't we circle our answer? Dun, 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 dun. An equation of a circle is given below. Identify the center and the radius, then graph the circle. First thing we want to do is write the formula for, write the standard form of an equation of a circle. It is actually x minus h quantity squared plus y minus k quantity squared is equal to r squared, where r is greater than 0. Now, hk is just the center. It's actually not on the circle. It does give you the center of the circle. And our goal now is to make this equation that's given look like that standard form. And the way we do that is we use a very, very popular trick in any algebra course, and that is called completing the square. First thing we're going to do is factor out the 4 from the x squared and the other x term, and let's see what that looks like. 4, and then we have parentheses, x squared minus 4x, and then I'm going to leave a space here to complete the square, and then we have plus what? We're going to do the same thing for the y terms, plus 4, parentheses, and then we got y squared plus 3 plus 3y. Awesome. Is equal to what? Is equal to 39. 39 is still on the right side of the equation. So why don't we complete the square? And when you complete the square, you have to have this x squared plus bx, or x squared minus bx. In this case, b is 4. What you do is you take that 4 divided by 2, take that 4 divided by 2, and then you get 2. And then you take 2 and you square it. And where do you put that 2 squared? You put it right here. Let's do it for this term as well. Here you have a 3. Okay, this is like y squared plus by. Here we have a 3, so we have 3 divided by 2, which is 3 halves, and then you square it. Make sure you don't use decimals here. You just sort of make your life very, very difficult if you use decimals. So keep it as an improper fraction. 3 halves squared is plus 9/4. Aha. Gorgeous. Now, this equation currently is imbalanced. If you look at the previous equation, it should be equivalent to this. Well, it's not, because all of a sudden I added 16 and I added a 9. So I can't add a 16 and a 9 all of a sudden. So the way I balance this equation is simply add a 16 here and add a what? Add a 9 here. So I added a total of 25 to both sides of the equation, and now it is balanced. If you're still having trouble seeing that 16 and the 9, well, there they are. Okay, you got to distribute that 4. Now we're in good shape. What does this look like? 4. The next equivalent equation is this. Beautiful. And then over here we got what? Y, you gotta remember what you did, plus 3 halves, right? And then quantity squared. That's what happened in completing the square. I'm gonna fix this little mark there. Is equal to what? 25 plus 39, dun 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 dun. That is 64. Oh, what a nice number. What is so nice about 64? I'll let you think about it. Now we want to get this into this standard form. So we don't want this coefficient of 4. Both of these have coefficient of 4 here. It's not a coincidence. It's actually, it should be, because this is an equation of a circle. So what we're going to do is divide the entire side by 4. And we could do it with common denominator. So why don't we do it like this? Divide this entire side by 4 by using common denominator, and then divide this entire side by 4. And let's see what we get. We get x minus 2 quantity squared plus y plus 3 halves quantity squared is now equal to 16. Remember, you're trying to identify the center and the radius. So the center here is what? 2 comma negative 3 halves. And the radius is always positive, so it's actually r equals 4. Now, we also need to graph this. And let's see. It looks like we are in the third quadrant, so I'm going to make more room to graph this in the third quadrant. If you have graph paper, that always helps. So I'm going to draw some axes here with a straight edge. And, you know, if you don't have graph paper, well, do your best. Label all your ordered pairs. Label them as well as you can. So my axes are like that. And here's the x number line, y number line. We call this the Cartesian plane. And let's see here. Why don't we do a scale of some sort? Let's try this. -1, -2, -3, -4, -5. And then I'll label that -5. How about that? Now we do have 2 and -3 halves. Oh, I'm actually in quadrant 4. Excuse me. I thought I was in quadrant 3. Well, let's see if I can make this work. 2 and -3 halves. 1, 2, 3, -3 halves. I'm going to mark the center right there. So, oh, -3 halves. Excuse me. I must be having an off day. Let's try that again. 2 and -1 and 1/2. 2 and -1. Right there. Yeah, there we go. That's much better. I marked it with a little star. That's the center. So that's -1 and 1/2. So if you went down 4 units, you should have what? -5 and 1/2. So I'm going to put a -6 here. And I'm going to put an actual ordered pair that's on the circle. It's right there. Now, remember, it has radius of 4. So that distance from that blue dot, or from that dot, to the center of the circle is actually 4. I'm going to do that similar approach by plotting 3 more ordered pairs. So this is 2, and I got to go, what? 3, 4, 5, 6. And then we go, da-da! And then we do the same thing on this other side. 1, 2, 3, 4. 1, 2, 3, 4. And I'm going to plot another dot here. Da-da! And of course, we're going to label all these, because label it gives you confidence. It gives you certainty. Okay, let's go. Ooh, this one's a little bit tougher. So this one is -1 and 1/2. So if I had to go 4 units, I'm going to count 4 units from here. 1, 2, 3, 4. So you're really at 2 and 1/2. So I'm going to put a 3. I'm going to put a 3 right here. And then I need to plot another ordered pair right in between the 2 and the 3. And then, of course, connect the dots. And we're going to label everything. You could either label on the graph when you're doing this on your own paper. Highly recommend that you draw this on your own paper first. Okay, the drawing is a mathematical skill. So there's a couple ways to label your ordered pairs. One is to label them in a T-chart. So remember, this one was 6, and this one was -2. So we have -2, and we have -3/2. So that's one of the ordered pairs. We also have 6 and -3/2. We also have 2 and what? 2 and -5 1/2, so -11/2. And then we also have 2 and 2 1/2, which is 5/2. We have 5/2 here. Let's circle our answers. It says identify the center and the radius and graph it. And when you're graphing it, make sure you label your ordered pairs. You either label your ordered pairs in the T-chart, or you could label them on your graph. You know, some people would actually prefer to label them on the graph, especially when you're doing your own graph paper. Some people would do this, put the ordered pair right there. That one would be what? 2, 5/2. Or, of course, these are already labeled in a T-chart. I think you get the idea. Also, your work is very important. Your work is what led you to the answer. So make sure you probably should pay really, really close attention to your own work. So it doesn't hurt to circle what work you need to show, to get full credit. It says to write an equation of the circle with center, parentheses 2, -9, parentheses, and the radius is 7. Well, circles are a big part of our lives. Everywhere you go, you can see circles. And sometimes, even if you look at your GPS, sometimes, if you look at your GPS very, very closely, it gives you a radius. Or sometimes you could say within 5 miles. And then you see a blinking blue dot on your GPS saying that's your location. That right there is sort of like what's going on here. Your location is 2, -9, and let's say you're within 7 miles. And if we wanted to draw that circle, we certainly can. First of all, write the standard form of a circle. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Well, gee, we're almost done. HK was given. Remember, HK was given to be 2, -9, and now we just simply substitute. What is our answer? X minus 2 quantity squared plus y minus k. That means plus 9. And then square it, and then r was given as well. R is always positive. So it's 7 quantity squared, which is 49. And there you go. There's your equation of a circle. Circle all the work. I'll circle the final answer. There's your final answer. And then maybe circle all the work that you should show as well. Transforming the graph of a rational function. Below is the graph of y equals 1 over x. This is one of the basic graph of a rational function. It is actually two hyperbolic branches. And so there's a branch here, and then there's a branch here. Now, be careful. When you're drawing this on your own sheet of paper, make sure you draw the arrows at the end to match the domain and range. That's very, very important. You got to read this very, very carefully. It has to match the domain and range. Depending on how you want to approach this, some students would actually draw this on a separate sheet of graph paper. But the intention here is if you could draw it on the same set of axes, you could see the transformation a little bit better. So there's definitely many ways to do this, but I am going to make use of some of these transformations. Like this one here says to go left 3 units. And then this plus 4 here says add 4 to the total y value. Add 4 to your y value. What does that really mean? If you add 4 to your y value, add a positive 4 to your y value, it really means what? Move up 4 units. Okay. So we could take an ordered pair here on your 1 over x. I guess I could draw a t-chart. So let's say this was x and this was 1 over x. We could certainly take 1, comma 1 and move it. And if you move it, our goal is to get a final product. Let's find this final product to be what? This final product would be x and then what? 1 over x plus 3 add 4, right? So if you took that 1 and move it left 3 units, this way, this way, this way, you're actually at -2. And then -2 for your x value. So here you're at -2. And then you got to go up 4 units from that position. Let me go back here. 1, 2, 3, right here. Now from here, you want to go up 4 units. 1, 2, 3, 4, which is that 5. Now, that seems quite complicated. So sometimes it's actually just easier to pick ordered pairs. It really is. So it's almost like saying, you know what, why don't I transform this -1, -1, well, that was on the original graph, but sometimes it's just easier to pick ordered pairs to put in here. I am going to do one more transformation. Let's go ahead and transform -1, -1. Yeah. So let's go ahead and find. Oops, I'm missing something. Okay, we got to go left 3 units. So I'll be -4. No problem. And then from that y position, we got to go up 4. The y position there was -1. So if you go up 4 from -1, you're at +3. So we're going to plot -4, 3. What color should I use? Why do we use black? -4, 3 is here. And then -2, 5 is here. The other thing you need to move are your asymptotes. Make sure you move your asymptotes as well. So there are asymptotes that need to be moved. We're going to move the y asymptote, the one that goes horizontal, 4 units up. So if you move that, draw it like here. And then you got to move your vertical asymptote as well. I guess I could draw this one to be black. How about that? So that's the one that got moved. We got to draw the vertical asymptote from the original graph. And we got to move that one which way? Well, it says to move it 3 units to the left. So if I move it 3 units to the left, I have a vertical asymptote here. Now remember, this new graph here. Apologize, let me make that neater. That should all be in black. That's that's better, right? Let me fix this other side as well. Okay, let's put the black back on. And we are ready to draw our nifty little transformed graph on the same set of axes. Now, when I first did this, I actually would draw this on separate pieces of graph paper. It actually looks messy. But there you go. There's the transformation. How do you show work on this kind of stuff? The best thing to do is show t-charts. Show your labels. You could always label your ordered pairs in a t-chart. So this is the necessary work. You should also rename your vertical and horizontal asymptotes. So let's rename those. So horizontal asymptote is now y equals 4. And then vertical asymptote is x equals -3. And so in order to get full credit of the transformation, you should show a little bit of work. This work here is necessary. And then what is the final answer? Of course, the final answer is the graph, right? So make sure your work matches your graph. Some of you will actually describe it. So if you describe it like I did here, this will count as work as well, but you have to write it with a description. So you can circle that as well. Okay. Oh, the other thing, of course, is make sure your graph matches with your work. That's very important. Doesn't make sense if they don't match. Right? So all this stuff here, this stuff here, all this stuff has to match. Yeah. Matching graphs with rational functions. And each of these have 2 vertical asymptotes. Now, this is sort of a strange question. You shouldn't say matching graphs. It should just say draw graphs. And so that's a big hint for you. The best thing you can do is just draw this graph by hand on your own with your own sheet of graph paper, and make sure you label all your vertical asymptotes and horizontal asymptotes. So I'll give you a hint here. I'll get you started with this problem. And so I'll label the first function with this color. Here you can see that the horizontal asymptote here is going to be y equals 0. Now, our goal is to find the vertical asymptotes, and that also coincides with your domain. So let's look at the domain. We know that x squared minus 4 can't be 0. So that means x plus 2 and x minus 2 can't be 0. Therefore, what are your vertical asymptotes? Your vertical asymptotes are x equals 2 and what? X equals -2. And then from there, I recommend that you just graph this thing. And so you would actually just start graphing this. There's no matching involved at all, to tell you the truth. It's just sort of silly. It makes you think there's something to match. There isn't. You just got to graph this on your own. Graph this on your own, and then try to match things. It should just say graph the function. So draw your vertical asymptotes. Draw your horizontal asymptote. Label things as well as you can. Use graph paper if you got it. That would certainly help. Graph paper always help. I was poor going to high school, so I never had my own graph paper. I always had to draw my own. But you just so kind of helps with being a teacher. I tend to draw a lot on my own. But so yeah, and then just pick ordered pairs. I mean, this one here was -2, and then this one here was labeled 2 in the x direction. So you might want to just pick a lot of ordered pairs now to figure out what's going on with what? X and 2x over what? X squared minus 4. Just remember, you can't pick -2 and 2. I would pick an ordered pair like -3 and -1 then maybe a 0, and then a 1, and then a 3. And this will help you figure out, that you're really not matching anything. The best thing to do is just draw these graphs on your own. I can give you a hint on the second graph as well. Since the degrees here are the same, we could see that the horizontal asymptote is simply the coefficients in front of the term with the highest degree. So the coefficients are what? 1 and 1. So your horizontal asymptote here is y equals 1 over 1. That's another way of just saying the horizontal asymptote is y equals 1. And of course, how do you get the vertical asymptotes? Similar to it's going to be very, very similar to the process of what? Getting this quadratic to factor and then indicating its domain. Okay, the vertical asymptotes. Once you figure out what the domain says, then you can also find its vertical asymptotes. That's my hint to you. So here's writing the equation of a rational function given its graph. This is a very interesting and puzzling problem. So what's going on here is that you're given pieces of information, you're trying to put them in some kind of structure or order, and then with that structure or order, you're trying to yield a result. It's sort of like what scientists and engineers and mathematicians do all the time. So this simulates the scientific thinking that is required when you're a STEM major. So you're going to be given pieces of information, and you have to understand what it says, and then put the big puzzle together and see if you could come up with the appropriate model. We're actually modeling. So you could think of function here as a model. And a model is basically to predict, a model is used to predict other information. So the equation for f of x has one of the 5 forms below. Choose the appropriate form for f of x and write the equation. You can assume that f of x is in its simplest form. That means it's in its reduced form. All the common factors are reduced. Let's go back. Let's go back to the vertical asymptotes. Let's try to translate some of these pieces. We're already given a name of the function. It's actually called f of x. So if you look at this part here, it says it has vertical asymptotes, x equals 1 and x equals -4. So we're talking about rational functions. So that tells us that we have factors like this in the denominator right off the bat. Now we don't know what the coefficients are, but let's just keep reading. It says you have to have a horizontal asymptote of what? Y equals -4. So if I took this information here, well, I'm going to need a coefficient of -4 in the numerator. Well, hopefully. Hopefully it's -4. It works its way up to the numerator of -4. This also tells us that we have to have a degree 2 polynomial up here, right? We need a degree 2 polynomial in the numerator, or else, you wouldn't be able to get the horizontal asymptote. The graph has an x-intercept at -2. Ooh, that helps a lot. Has an x-intercept at -2. So when y is 0, we have to have an x-intercept of -2. So when y is 0, we have to have an x-intercept of -2. So that means f of -2 is equal to 0. Maybe I should write that like that. F of -2 is equal to 0. And where did I get that information? The graph has x-intercept -2. That's how I translated that. And it passes through the point -3, 1. So we also know that f of what? F of -3 gets you 1. Boom, 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 boom. So far, what do we have? We have something like this. X minus another a. And then, well, let me see. If I had to guess, let me see, x minus a times the quantity x minus b. We could maybe guess it looks like that. Now, putting a little bit more information together, I really think I have this going on in the numerator. So I'm going to rewrite f of x one more time. F of x is now equal to, let's say, negative 4. And I want a x plus 2, right? Ooh, that's going to help a lot. So I got a lot of the form now. And then what's left is just a, let's say an x minus b. Doesn't matter what letter I use. Now the denominator, we're pretty clear on. The denominator, we're going to say it's the factor x minus 1 times the factor x plus 4. So do any of the forms below match this kind of prediction? Let's see. Right here, right? Doesn't it look like this? Yeah, it doesn't matter what letters we use. So there it is. It's going to be like this. The only letter we're missing is B. So how do we find B? So you can certainly pick this selection here. Why don't I circle that? I don't think it's very important. I think we should find B first. Why don't we find B before we circle our selection? Let's find B. How do we find B? Why don't we take this information here and use it? That information there says f of negative 3 is what? F of negative 3 is going to be an output of 1. So why don't we use that? 1 is now equal to negative 4 times what? Negative 3 plus 2 but then what do we have? We have negative 3 minus b. Minus b. And close it. And then put that over what? Put that over negative 3 minus 1. Negative 3 minus 1. I'm probably overdoing it with the color coding here. And then we have negative 3 plus 4. All right. Well, that's not bad at all. Let's rewrite this. 1 is equal to negative 4 times negative 1, which is positive 4. That's a b. And what's in our denominator? We got negative 4 times 1, so that's negative 4. Oh, that's cute. We got some factors reducing. So 1 is equal to negative 3 minus b. And we have a plus 3, so let's subtract 3 from both sides. And we get b. b is equal to negative 2. Aha! Gorgeous. Gorgeous, gorgeous, gorgeous. I'm going to go back and call this triple star. Go back to triple star and we're going to substitute our f of x. f of x is equal to negative 4 x plus 2. And then we also have a what? Another x plus 2. And then over x minus 1 and an x plus 4. That is the model of all the pieces of the puzzle. Let's circle the model.